In 1974, a new hypothesis explaining the origin of Earth's moon debuted on the world's scientific stage. Its proponents dubbed it the giant impact theory.
The basic idea is that about 4.5 billion years ago, Earth collided with an object roughly the size of the current planet Mars. It's a very large collision, and it started the Earth spinning. It's what gave us our current 24-hour day, we believe. And this collision was so massive that it launched material into orbit around the Earth, and it's from that material that we believe the moon later coalesced.
Dr. Robin Canup and others at the Southwest Research Institute in Boulder have constructed a computer model to study the details of the giant impact scenario.
It divides up the Earth and this colliding rogue protoplanet into many different particles, and then the evolution of each particle is tracked through the course of the impact.
The simulation depicts the impact from a bird's eye view from the top down.
The Earth was probably partly molten even before this impact. So initially, the impactor came in from this direction. It hit the Earth with an off-center collision. And you can see the impactor has been stretched out into this long arm of material right here.
Scientists believe the upper layers of the Earth became completely molten following the impact.
The collision starts the Earth rotating. And you can also see that the collision has substantially distorted the shape of the Earth itself. After a couple hours, we see that this arm of impactor material has coalesced gravitationally into two large clumps. The inner clump of the impactor material is actually composed overwhelmingly of the impactor's core, so that when this inner clump recollides with the Earth, which happens right there, the vast majority of the iron that came in with the impactor is actually accumulated by the Earth. While this outer clump comes in and makes a close pass by the Earth and is stripped by the Earth's gravity into a long arm of material, which then breaks up to form this disk.
The material is thought to have coalesced to form the moon in less than a year following the massive impact. There is no sign of this impact on the Earth today, because at the time, our planet had only developed to about 90% of its current size. The remaining 10% would accumulate from later, much smaller impacts. Also, the Earth's own gravity had a reshaping effect.
Within a day after the impact, the Earth had reassumed a basically spherical shape, and any depression that the impact caused would have been smoothed over.
Giant impact theory originator Bill Hartman presented his hypothesis at a scientific conference in 1974. But it received little attention for nearly a decade. Interest in the moon dropped off sharply at the end of the Apollo missions.
Beautiful, very clear, very quiet ride.
Finally, at a lunar conference in Hawaii in 1984, 12 years after the last moonshot, the world's foremost astronomers reached a consensus. The giant impact theory was the most acceptable explanation to date for the origin of the moon.
I think there's still some people who say, okay, it's not really proven yet, but it's what I would call the default theory. If you look at any textbook of planetary science or geology, it's just the theory that's accepted. And there are certain small discrepancies which have yet to be explained, but by and large, it works.